that has 4 layers. It has 4 layers. Why the OSI is theoretical layer, theoretical framework for protocol, which has a network protocol which has 7 layers. 7 layers. You can write it down, and you can ask question after now regarding that, or after the if you still have time, you can ask question, or you link with me regarding that. So it has OSI has 7 layers. You can put that down. That is the theoretical framework for network protocol. But for the practical network protocol, we have TCP. Okay, good. I believe you can hear me. If you can hear me, can you hear me? Or are you following? Are you following? Can I see you? Can I see a thumbs up? Are we together? Okay, good. All right. Let me proceed. Now, the OSI, I told you we have what? There are two. Let me just put it there. Let me put it in order to to avoid some ambiguity in that regard. Okay, so let me put the word yeah. Okay, let me just put OSI and TCP. Okay, TCP/IP model. Okay, so these are the framework. We have one theoretical framework, and the other one is the practical framework. Okay, so now looking at that, for the TCP/IP address, what is the full meaning of TCP? TCP means transmission control protocol, and IP means the internet protocol, like I said earlier on. This is the standard used to communicate over a given network. Is the standard that must be followed to communicate. If this standard is alternated, then there won't be something called communication. Okay, this helps to visualize. Are we together? This helps to visualize how data is organized and transmitted across the network. It helps to organize, like we studied the data packet initially. It has 4 body, and I told you a letter you are sending that has an envelope. The envelope is not the one that actually has the main message. The main message is inside the envelope. So when it reaches the recipient, or the receiver, or the person that the letter is intended to be sent to, the person will remove the envelope and throw it away. Okay, because the envelope has done whatsoever thing it will do. So the person will now take the letter and read. The same thing applicable here for TCP. The real message must be removed. So each layer 4, we have 4 layers. As it reaches one layer, there will be the layer that covers that data. Data is going to be removed. If it reaches the other layer, the envelope of that layer 2 is going to be removed. You are going to see that. Then after it reaches the 3rd layer, the last envelope will be removed. Then it will be the 4th layer too also will remove its own envelope. Then the message will reach the person. That is what we call application representation. Okay, so if you look at this here, we have the 4 layer here. We have the first layer. We have what? The network access layer, followed by the internet layer, and followed by the what? The transport layer and the application layer. Now, if you look at that, the network layer has its own should I say element that wrapped the real message. Why this also has its own? Until it reaches the what? Application layer. That application layer is where the real data, the real data or the real resources will be what? Will be seen. I believe you are following me. Okay? I believe you are following me, right? Okay. Now, if you look at that, I equally put note under that. I say when a data packet is sent and received across a network, it is assigned a port. You know, I've told you that already. In the head, it has a port number as well. In the head section of the data frame, it has a port. Now, the address, let me give you an instance. Maybe in a school now, let's say University of Ilorin. University of Ilorin has different faculties. So if I am addressing a letter to a particular faculty in the University of Ilorin, and the address, I didn't include the name of the faculty, I only addressed the name of the school. The letter will be dropped in the school, because it will be dropped in the school. Yeah, the person will deliver it, but the school, when they receive it, they will be looking to whom has this letter been addressed to. So the name of the faculty in this state stand as the name or the number of port. When an information is sent to my system, now it will be expecting which of the ports are you sending this message. Okay, I want to print. Let's assume I want to send or access internet. The type of protocol, the port number is 8080 or 80. Sometimes it could be 5000, sometimes it could be 3000. So that port, your system, your motherboard, you are sending the information reaches your motherboard. Okay, I wish we have the practical the physical action of this. Okay, now when it reaches your motherboard, your IP, it located your IP on the your IP address, and it comes to my system. So that information, that data packet, what is it doing? The instruction on what to do is also embedded in the S section as port number. So if it is 80 or I'm trying to send message, it's going to carry the port of the message port number. That it, as you can see it here. Can you see it now? For the email, let's assume is the email I'm trying to do. It's going to be what? It's going to be 25. That is email. Have you ever seen something like this before? For the developer amidst us, if you have ever seen something like this, you see 192.168.10.1, then you see something of this nature. I think you've seen something of this nature before. Let me say 8080 or 80 or whatever. So this particular port, this is a port. Anytime you see this one is IP address. From here to this place is what we call what? IP address. Okay, and of course the reason why you don't see it in Google, like Google now, if you say Google, that is www.google.com, you will see this is what we call DNS, domain name system. And why are we using that? So that the people, it will be readable. How many of us can know that Google? Okay, let me give you the Google IP address so as to see. Okay, so the DNS is used for human understanding, so that human will be able to understand. Okay, this is Google. We cannot be cramming 192.0 No, we can't be cramming that. So we need something that will be easier for the user to remember. Something of this nature for Google now. For Google, that's google.com. The IP address is this. Can you see? That's 8.8.8.8. That is their address. Okay, now nobody, is only computer that understand this. You get it faster. As soon as you press it in your browser, the browser converts it into what? Into this number that we know as what? IP address. So now let me proceed by what I'm saying. So everyone, if you are a developer here, I believe you have seen something like this. Probably when you are trying to develop React application, probably backend or front end for React, or probably you are using Laravel, or you are using Flask. So if you run Flask application, which is the backend for Python, right? So you will see something of this nature. Then you will see column and the number following it. That number following it is what we call the port. So that is telling the computer what to do and what to do when the receiver receives that. Okay. So is a port is a software based location that organizes the sending and receiving of data between devices on a network. Is so and so on and so forth. So the number gives the instruction. So why do we need the port? That is, it gives instruction. It gives instruction. It gives instructions to the receiver end. Are we together? Are we together? If you are together, can I see? Are we together? Okay, okay. All right. I believe I'm not too fast. And if there is anything you want me to re-say or re-explain, please let me know. Let me know. Okay. So now going forward, having seen, having looked at the data, packets and all, the medium that this data packet passes, we have talked about it, that we have two type of medium. It could be wired or wireless. So let's look at the physical one, wired. So I believe after now, everyone here will be able to crypt wire, will be able to crypt cable for cable very very professionally. And if you are here, you know how to clip it, you will equally attest to what we are saying today and the proper way of doing it. The proper way, like the moderator said, the proper way, the best practice on how to go about clipping um, wire. So now let's look at the wired medium. As you can see, it's a physical one. We have A, we have B. The A and B are terminal. When you buy wire in the market, let's say you buy twisted, we have different type of cable actually. We have quartz and which one again? Okay, we have twisted pairs, of course, cable. Okay, so now the first one, the former one, is actually used for antenna. I don't have the copy with me here. I've shown you. Okay, okay, all right, are we together? Okay, good. So here we have the wired medium. How creating wire medium for network kinds. Okay, there are various type of cable which are used for various purposes. So we have various cables, and each of these cables has its own purpose. That's just it. Okay, the Ethernet cables are numerical based categories. Hence we have cat5. That cat means category. The 5 is just an to to create the, to make, how am I going to put it now, differences. Yeah, the differences between those wire. We have cat 3, we have cat 4, we have cat 5, we have cat 6, 7 and 8. You will see that now. So the E, now somebody will now ask, we have cat 5, we have cat 5E. What is that E? The E mean enhanced. I know you might not have known this before, the enhanced, the E enhanced, but you've been hearing cat 5, cat 5, cat 5E, wherever. So the E there mean enhanced, and there are differences between the cat 5 and cat 5e. So meaning there are features that are added, to the previous version of cat 5. That's why the addition of what, of that E. Okay, now and etc, we have all most of them like that. We are going to see that as we progress. Now note, for every physical medium, For every physical medium, this must be physical. Now we are not talking about wireless. We are not talking about what? Wireless. We are talking about the physical. Now, for every physical medium, there are two terminals. Like you can see here, we have A and we have B. Okay? We have A and we have B. There are two terminals, say A and B. So therefore, let's say terminal A is what? Alongside with the sender PC. Terminal B goes into the receiver PC. Okay? So now, there are two terminals A and B. Therefore, there is a type of connector called RJ. And what is RJ? RJ connector means registered jack. Registered jack. So we all heard of RJ5, RJ45, RJ11. RJ45 is actually used for Ethernet connection, while RJ11 is used for line phone connection. Okay, so we have that is that is expected to be fixed into the both side of the cable. So we fix the RJ here, we fix it at the other end of the cable. You are going to see that you are going to see the steps that you need follow whenever you want to create such a wire. We are creating the wireless. So if you look at that, we have different types. Like I have said, we have cat 1, we have cat 2, we have cat 3, we have cat 4, we have cat 5, cat 5e, cat 6, cat 6a, cat 7, cat 8 and all. Okay, we have cat 8 and all. So moving forward, there are two types of twisted pairs. That's another thing we are looking at. We are looking at the cable, okay? Either cat 5, cat 6, whatsoever. We are talking about their nature now. There are two types of this twisted pair cable. So we have one called UTP and STP. What is UTP? UTP means unshielded twisted pair. Unshielded twisted pair. And we have STP, that is known as shielded twisted pair. Okay, UTP, unshielded twisted pair. What does that mean? Now, this shielded has something, this networking is very, very broad, and what we are bringing to you now has already, demystified everything about networking. From here, whosoever that have not even have no experience in that networking now has already turned out to be a professional through this section, I believe. Now, why shielded? Why shielded? Because there is a limitation to UTP. UTP as unshielded twisted pair, it does not prevent what we call crosstalk. Okay, it does not prevent such. So, and also there's something called attenuation. If you go deep, very deep into networking. So in order to treat, or in order to should I say eradicate or reduce such crosstalk in the cable, we now have what we call STP, which is shielded twisted pair. It's like if you have open wire before, that cable before, you will see small brown, or or is it brown? Brown leather, or should I say leather, or insulator round about those twisted pair of wire. Now let me just give you the description of the wire. The wire, this twisted pair cable has four pairs. It has 4 pairs in it. Each pair has 2 wires. Okay, it could be green and green white, yellow and orange and orange white, brown and brown white, and so on and so forth, blue and blue white. Okay, you are going to see that. Okay, so that is it. We have 2 types. Just put that in your mind. We have 2 types. We have UTP and STP. At the end point of each cable, we fix the RJ45 and on and so on and so forth. Now, in fixing connector, you can't just connect the wire to the RJ45 and you say you have connected network wire. No, you have to follow rules. You have to follow rules, okay? In doing that, that rule is called what? Color coding scheme, okay? Color coding scheme. You can't just connect red to red, white to white like we normally do in a regular electrical connection. You have your wire, if you see red and red, you have to join it together. Black and black, you join it together. That is not networking. In networking, you have to follow what we call color coding scheme. And what is that color coding scheme? We are going to see that first and foremost, the RJ45 connector has 8 pins. Of course, I've said that. Has eight pins, of course. If as it has 8 pins, so also the cable you want to fuse inside it has what? 8 wires, which is 4 pairs, okay? Now note, there are several kinds of connectors that closely similar to RJ45. I say RJ4011 connector is used for telephone cable. Actually, it's used for telephone, and if you see it, it's very small. It's smaller in size and also narrow. It's very narrow compared to RJ45. We've seen it before. We've seen that before, I believe. Okay, most of us might not pay attention to that, but if you have a router with you, most especially anything like MTN router, if you look at the back of it, you will see a very narrow RJ47 slot there. Okay, you will see it there. It's there. Okay, now color code scheme. RJ45 connector data cable consists of 5 pairs of wire. Each consists of a solid color wire and a strip of the same color. Can you see? Now there are two wiring standard for RJ45. There are two standards for RJ45, and we are going to touch all of this. There are two standards. Am I communicating? Okay, good. Okay, right, good. All right, so there are two standards. One is very simple. All this one can be learned by heart, of course. You don't need to cram it, you can just know it. It's very simple. That's T568A, T568B. So these are two standard when wiring RJ45, when clipping, we call it clipping, or connecting the cable to the wire. Okay, moving forward, if you look at that, those are the standard. Let me show you the so that is the color code. Can you see it now? Can you see? Okay, I think we can. Let's look at this color code. There are 2 pins or 2 pair of wires. Now this pair of wire could either be 10 base T or 1000 base T. Ethernet uses only 2 wires pair, which are orange and green. Yes, the fact is that the RJ45 that we all know, we all see around us, most especially in our university or wherever you're working, or you have used it before, you will see that there are 8 wires. That's 4 pairs of wire slotted into what? Into RJ45. That RJ45 connector that has 8 pins in it. Okay, so out of that 4 pairs, or let me say 8 wires, out of that 8 wires is only 4 wires that are actually used in Ethernet, in the internet. Okay, there are only 4 of them used. The other one are not actually, they are just there. Okay, so now look at it. Orange and green. The orange and green, if you look at it, the other 2 colors, blue and brown, are used for the phone communication or connections. I believe you can see what I'm displaying, right? Can you see it? If you can see, let me can you see it? Can you see? Hi, are we together? Okay, are we together? Okay, are we together? All right, all right. Now, if you look at that, that's the color code. Now, if you look at this, we have the T568A and T568B. T568A, if you look at the color code, we have this is the wire visually, okay? We have green, white, we have green, we have orange, and we have blue. You can see the pattern changes. The pattern here changes, okay? Now we have blue, white, we have what? Orange, then we have what? Purple, and white and purple, okay? So these are the most important one we put eyes on, okay? This green, that's 1, 2, 3, and number 6. 1, 2, 3, and number 6. Then if you look at that, the other part of it also, you will see. Are we together? I believe we are together, okay? All right, now, good. Okay, we are together. Correct, yeah. All right, now, looking at that, let's see the slide. I believe you can see the slide there, right? Okay, good. All right, now, you will see that this type of T568A standard and T568B standard, you will see they are different. Okay? Now, for the for T56A standard, the first color you need to, the arrangement is green, white, and white. Green, white, and green. Then orange, white, and blue follows, okay? So arranging your wire in this form, that means you are following T568. So if you have already you've already crypted the cable inside the are we together? If you have already crypted your wire inside the connector, RJ45 connector, the other end must be like this. You don't go and use this. You don't use orange, white. No, it's not going to work, okay? So having initiated your connections to be like this, to follow this standard, the other part, the other terminal, or the terminal B, must follow this pattern. It must be what? Green. This is type of, we call this one straight cabling, okay? This is the straight line cabling, okay? You can see green to green, white to green, white, green to green, yellow to yellow, and so on and so forth. Are we together? Now, the second form of T568A is in what we call it crossover. Okay? Crossover. When you are crossing over, the one of green, white goes to what? Goes to number 3 of green, white. Can you see the arrangement? Green, white here of the terminal A goes to the 3 of terminal B, okay? Now, if you see the second one, we have green of this one goes to the number 6. Then number 1 of this one goes to number 3. And number 2 of this one, T568A, the crossover cable, number 2 goes to number 6. Yeah, number 6, okay? While other ones follow the same pattern. So the color, so that is how it goes. You have to follow the color scheme, okay? Without that, it will not work. It's not a normal electrical wire that we have home, okay? Now, going forward, so if you can see that again, so if you need the slide, I will make that available available. So moving forward, let's go to the next. Let's see the color code as well. Most of the time, many people who are into networking, they find it difficult to creep wire successfully. Many people creep wire and the wire will not even allow passage of data packet. Why? Because it's wrongly fixed, it's wrongly creeped. So if that is the case, therefore you have to do it properly for it to pass what information. Okay, so it is very very essential you understand this scheme we are talking about. Are we together? If we are together, let me see your high. Okay, good, good, good. We are together. All right, okay, good. All right, now you can see that also. You can see that. You can see this. So this is the color code, which makes it easy for us. So this is pin. That's it, pin 1 to 8. This pin represent what? It represents all the 8 wires of the twisted pairs, and also represent the pin of RJ45. Okay, it represents all the 5 RJ45. We are going to see that by as we progresses. Okay, excuse me. Yeah, okay. All right, now the next slide we have now, how creating a cable, crypting a cable to RJ45 connect